AC circuit containing only inductor, or I can say a pure inductive circuit. So here I consider this is my inductor having inductance L connected in series across this alternating source of EMF E equal E naught sine omega t. Okay, so this is my applied alternating EMF. Alright, so if you remember in electromagnetic induction, because of this changing current, or I can say a varying current is passing through the inductor, then the magnetic flux that is linking with the inductor will change. So that changing magnetic flux will set up an induced EMF in the coil. So that induced EMF, it will be opposite to the current which is sending by the source. And the magnitude of the induced EMF, it is equals to how much? Okay, this induced EMF which is set up in the coil is equals to minus L di upon dt. Okay, so this is my induced EMF and this is my applied EMF. Now the magnitude of the induced EMF and the applied EMF, it is same, but the difference here, it is only the direction. So if that is the case, then I will write E is equals to minus of minus L di by dt. Okay, or E is equals to L di by dt, or in place of E I'll write E naught sine omega t, and this is equals to L di upon dt. Next, if you find out di from here, you will get E naught sine omega t dt, and this L will come down like this. Okay, so this is my di. So if you integrate this equation both sides, then you will get integrations over the I on the left, and you integrate this E naught upon L sine omega t dt. Next, integrations of the I is equals to I. This E naught upon L are constant, so we take outside integration sign and we integrate only sine omega t dt. Okay. Next, this current I, it will be equals to E naught upon L. Now what is the integrations of sine omega t dt? We know integrations of sine mx dx is equals to minus cos mx upon m. So similarly, when you integrate this sine omega t dt, you will get minus cos omega t upon omega. Alright, okay. Or I will say this current I is equals to minus E naught upon L. Okay, I'll write like this, omega L. And okay, if I want to get rid of this minus sign, then I will write this as equals to sine omega t minus pi by 2, isn't it? Because sine omega t minus pi by 2 is equivalent to minus cos omega t. Okay, or E here is equals to, I will replace this constant by another constant I naught. So I'll get like this. Okay, so this is the equations for the current at any instance of time t. Okay, how much is I naught? This I naught here is equals to E naught upon omega L. Okay, and this is known as the peak value of alternating current. Okay, so looking at these two equations, equation 1 and equation 2, here we have E equal E naught sine omega t, but in this equation 2, I equal I naught sine omega t minus pi by 2. So because of this minus sign, it means that this current I here, it is lagging behind the EMF by how much phase different? By a phase angle of pi by 2. So because it is lacking by a phase difference of pi by 2, then if you represent the two wave using a phasor diagram, then you will get a wave like this. This is my coordinate axis, in which x dash is the reference line. Okay. Now, if this is my EMF with magnitude E0, then the current here, I0, it will be lying below this E0. And because the phase angle between the two is pi by 2, it means this angle here is 90 degree. Okay. So this is the phasor diagram of the two wave current and EMF. Alright. Or if you represent the two wave graphically, then you will get a wave like this type. Suppose this is a wave for the alternating EMF. Then because the current is lacking behind the EMF by an angle pi by 2, then my current here will start from this point. Like this. Okay, so this is a wave for the EMF, and this dotted stands for the wave of a current. Okay, so as you know, this angle here, it is equals to how much? Pi by 2. This is 3 pi by 2. This is 5 pi by 2, and so on. This is 0. At this point, it is equals to pi. At this point, 2 pi. Please remember on this line always, right? The angle is always equals to how much? Multiples of pi. So this will be 2 pi. This will be, sorry, do I make any mistake? No. So this is 3 pi like this. Okay. So this is a graphical representations of the two wave, that is current and EMF, when the circuit is a purely inductive circuit. Okay. Now, coming to this equation, I naught equal E naught upon omega L. What does it mean? Okay. So, if you find out omega L from here, you will get E naught upon I naught. So, what is this E naught upon I naught? EMF upon current. So, we know EMF upon current is always equals to how much? Resistance. So, therefore, I can say that this omega L, it behaves like a resistance. But I will not call a resistance, because here we are using an inductor. If it is a resistor, then the resistance is capital R. But if it is an inductor, the resistance is omega L. But the name of this omega L here, it is known as, inductive reactant. So what is an inductive reactant? An inductive reactant, it is the resistance which is offered by the inductor in the circuit. Alright. And because it behaves like a resistance only, so therefore the unit of this omega L, it will be measured in ohm. Alright? Okay. Now, for this omega L, I will say this is equals to XL. Okay, so this is just another representations for the inductive reactant. So when I see inductive reactant, it means XL, and this XL is equals to how much? XL is equals to omega L. Okay. So let us discuss some special cases. The first case is for direct current. When the current is direct, that means the current is going in a straight path. Do you have any frequency in such case? No. So the linear frequency is equals to 0. So when the linear frequency is 0, look at XL. we have XL is equals to omega L. What is omega L? What is omega? Angular frequency. So if this is angular frequency, then we convert into linear frequency as 2 pi f and then with this L. Okay, omega can be written in terms of linear frequency as 2 pi f. But for direct current, f is how much? F is 0. So when f is 0, then 0 times anything will be 0. So XL is equals to 0. What does it mean? It means that this inductor, it will, because XL equals 0, it means the resistance which is offered by the inductor for a direct current is 0. Or we can say that this inductor offers 0 resistance for a direct current. It means when a direct current is passing through this coil, this current will pass freely without experiencing any resistance by the inductor. Okay. Now, what about for AC current? For AC current, we know F cannot be 0. There must always be some frequency. So because F is not equals to 0, then my XL will be equals to how much? 2 pi F times L. As F is non-zero, so XL also is non-zero. So when XL is non-zero, what does it mean? It means that this inductor will always offer resistance to the AC current. Okay, so the greater the frequency, the greater will be the resistance which is offered by the inductor. The less the frequency, the less will be the inductive reactant in this case. Alright, so this is about a pure inductive circuit, a phasor diagram, a graphical representation, and some special cases about inductive reactant.